Hi everyone, this video is for section 5.4, the other trigonometric functions. This particular problem that we're going to work at, our goal is going to be to simplify this expression that you see written in green to a single trig function with no fractions attached to it. So I'm actually going to offer two different explanations. The first one I'm going to go ahead and do in orange. So to begin, hopefully the numerator is looking a little bit familiar to you. So if you notice, this is kind of a remodified version of the Pythagorean identity, which states the cosine squared of t plus the sine squared of t is equal to 1. I know usually we use theta instead of t, so just to let you know, it's just a swap out of the variable. It doesn't change the meaning of the identity. It's just a change in symbol that we're working with. So notice that if I were to just modify this a little bit by subtracting, not that one, my fault, by subtracting sine squared of t from both sides, that I'm suddenly going to get a useful piece of information. I do see that I get the sine squared of t is now equal to 1 minus the sine squared of t. So notice that I've been able to match these up. I'm able to now say, well, 1 minus the sine squared of t is equal to the cosine squared of t, or it's the same thing. So I'm going to go ahead and rewrite and say that I have the cosine squared of t all over the sine squared of t. So at this point, go ahead and take a look at the ratio. I have a cosine in the numerator and I have a sine in the denominator. Never mind that you do have these squareds here. They just will kind of naturally follow into your final work. But again, the fact that we have this ratio that's happening here tells me that I can redefine this to be the cotangent squared of t. And here is my final answer. Notice that it does satisfy that I want a single trig function with no fractions in it. So I win. So let's go ahead and take a look at a second explanation, and I'm going to go ahead and do this one in purple. So I'm going to start fresh with the same problem. Okay, so let's begin. So first off, notice that your numerator has two terms. You have 1, and then you also have a sine squared of t. Notice the denominator has a single term in it. So what I'm going to go ahead and do is break this apart. So this is going to become 1 over the sine squared of t minus the sine squared of t all over the sine squared of t. Okay? So I've literally just kind of expanded this fraction out. Okay, notice that the denominator has not changed. I've just split it up amongst the different terms that are located in the numerator. Okay, so first off, let's take a look at term 1. I have 1 over the sine squared of t. Well, I can tell you by using our trig identities that this is the same thing as the cosecant squared of t. That minus sign goes along for the ride, and now we have a sine squared of t over the sine squared of t. Well, that boils down to a 1. Again, if you recall from your Pythagorean identities that we've been looking at, there is a Pythagorean identity that reads as follows. We have one that says the cotangent squared of t plus 1 is equal to the cosecant squared of t. So at this point, I'm kind of thinking, well, gee, if only I had a cosecant squared of t and a 1 all on the same side, and I can confidently tell you that that is possible. We will simply just subtract 1 from both sides of the equation. And this now gives me a new definition. We're saying that the cotangent squared of t is equivalent to saying cosecant squared of t minus 1. So we've been able to link them up, And now we can go ahead and say, alright, this boils down to the cotangent squared of t. And there is our answer. And if you notice, it's the same answer that we got using the first method. I hope this video was helpful. If you do have any questions, please feel free to reach out to me.